Anything else from my TAs?
I just wanted to screen share a picture that my student did. I
Oh,
sent
yeah,
it
yeah,
to you
yeah.
guys.
Yeah, do this, yeah. 1 second, I got to give permission. Where is it? Oh, I'm screen sharing at the moment. Yeah. There's my stop share, and then I got to give permission. Okay, you should be able to screen share.
Can you see that?
Not yet.
There it is.
Yep, there it is.
So one of my students did this on her own initiative. She just took a red, green, blue and stuck them together in Photoshop.
Oh, jeez.
Yeah, and she was really excited about it, and I was too. So yeah, I just wanted to share that with the group.
How did she align it in Photoshop?
I have no idea. I was like, this girl knows more about astronomy than I do at this point because she put this thing together. I was like, wow, this is impressive. It looks good too.
Yeah.
I mean,
Yeah.
and she also did this one, the Helix Nebula. So
Ooh.
yeah, so she took that with mech ring.
And so these are, of course, short exposures because we've only given them a half hour of time. So she used maybe 40 seconds per filter, I'm guessing. And
Yeah, whatever the setting was that
and
was
of
set
course,
in the
this
lab.
red, green, blue. You can also combine illuminance. Astrophotographers will combine one more frame of luminance to provide structure and detail.
Mm-hmm.
It's about how the human eye works, which I find fascinating. You can take an image, this is in the side, and you can break it down into it's like a black and white and the colors, and then you can blur the color frames out tremendously. Put it all back together, it looks exactly the same. So the human eye doesn't see color in great resolution. It's what our rods are doing, the black and white. So having that luminance frame, open, high through, whatever, can help sharpen them up a lot. Here, let me grab the screen share back and I'll show you a place that you can put this. And then we'll get into
At the top, Jared.
I'm sharing, right?
Mm-hmm.
Yep.
Find this quickly. So students have done this over the years. And this is just on the UNC page. We have a little link here for student astrophotography.
Oh.
Loading slowly, probably because of all the
Oh
videos.
wow,
Cool.
And so this is
those are really good looking pictures.
Yeah, this is without any training or anything. Now, one thing I should say, this past weekend, I just put, I'm gonna mute you, Judith, because you have some static, but feel free to unmute if you have stuff to say. I just put in a small grant this weekend, system-wide grant, and that will include building RGB and LRGB combination into Afterglow, which has always been our goal. We've just been waiting for the funding to do it. It will also fund things like image upload, which is I'm also funding through another route, so some additional funding there, and standard sky surveys and catalogs being directly uploadable into Afterglow as well. And so this is kind of building foundation for you to do color stuff. And if it is funded, and I think it will be, the competition seems perfectly written for the proposal I had to offer. But you know, I just jinxed it by saying that. I'll also do like a little, not a full-blown lab, but a set of directions on how to make color images in Afterglow. So if they have any extra time left over, they can play, and maybe it will, you know, eventually be incorporated into the multi-wavelength universe curriculum we hope to add. And also with Tim Spuck, we're putting in a large grant that will have color combination and a number of other things built into it that we're working on right now. But until then, some students just get ambitious and they do it on their own, and it looks, you know, pretty good for only having these short exposures. We have astrophotographers who also use the telescopes. And here, I'll just go to that page real quick. I have it on my personal home page under slow internet connection. I'm probably hooked to the wrong wireless in my house. Let me check. I am. If it gets bad, I'll switch to the other. Let's see. Prompt astrophotography. Now these people take hours of exposure time altogether, and these are just thumbnails. These are thumbnails of the ones that have become APODs. And they have many others. That's one group, and here's another group. We've produced like more than 24 APODs from these telescopes over the years. And maybe that's something you can get your students excited about, the ones who try in RGB. You may want to point them to this site. It's danreichert.com/astrophoto. And they can see what else is being made with those exact telescopes. And there are links, and the links provide information on how they did it. Some of them use narrowband filters and different things like that. Okay, so enough just fun stuff at the beginning. Let's see here. Maybe I'll unshare for a moment and do just some general announcements. First, I should just ask, how's everyone doing? Does anyone have any pressing questions from their experiences over the past week? Okay, I'll jump right in. So announcements, you all got the emails about the surveys, right? Even if you're not offering the OPIS curriculum right now, and even if you haven't decided whether you're going to use the WebAssigns or adapt the curriculum, you're still, a few people are still thinking about this. I would appreciate it if you did the surveys. This survey that we sent out is pretty small, 10 to 15 minutes. It's pretty standard stuff on student attitudes, student self-efficacy, which is whether they feel confident that they can do it. So attitudes is how they feel about the science. Self-efficacy is if they feel they can personally do it. And also career intention. And all kind of merged into one. It's, just these grids of questions. And it's a composite from a number of surveys that have been validated by Michael Fitzgerald, David McKinnon, and their students. So it's not just a bunch of questions we threw together. These are professional education researchers. So these have been demonstrated to be effective questions. And if you have started OPIS, do it. If you haven't started OPIS, do it, because we want to get that. If you haven't started OPIS, we want to get that baseline data. And they're pre-post, so you offer one at the beginning of the semester. We're running a little bit late, but it should still be mostly okay. And we're running, and then you give the same survey at the end of the semester, and we look at the gains. And you'll probably have gains even with your current curricula. And the question is, do you get bigger gains in these areas with the OPIS curriculum? Our preliminary studies showed that you did with student attitudes. We didn't test these other things. But that was only 700 students over 2 years. We'll hopefully get 700, maybe 1,000, maybe 2,000 students this semester alone.
I don't think I got that email.
You did not get that email because you're high school, and we can't give it to those younger than 18.
Gotcha, okay, no worries.
Originally, when we wrote the grant, we included a number of high schools, advanced high schools in particular, but we're just legally not allowed. We could, but we would have to get the proper IRB permission. As is, I was able to get an IRB exemption, which is much preferable from a management point of view. And it's not worth the extra hassle to bring in the 4 high schools we have, so sorry. I can send the survey to you and you can use it on your own fruition. It just, we can't incorporate it. One other thing I sent in a follow-up email, we need to get high response rates whenever possible, though it is optional. It says right on the front page, student, you do not have to do this, which tends to lead to lower response rates, but we have to tell them that. So, but you are allowed to incentivize. It is ethically acceptable for you to incentivize them doing this with like a bonus point on something. The issue was I didn't know how to tell you which students did it because I'm not allowed to share that. They put in their student number. I don't know their name. And the student number, they put it in just so I can match up the pre and the post. It's a unique number in your institution that no other student will have. They can make up a number too, as long as they remember it come the end of the semester. But we erase those, and I'm not allowed to send those back to you. But Brad Barlow pointed out that they could do a screen capture of the final confirmation page and send it to you if you want to deal with that hassle. It's totally up to you. So if you haven't already started, go ahead.
I've already got one screenshot back, so I'm happy
Excellent.
with that. I got one so far, so it's been 2 days or something, but
Good. And, you know, pestering, you send out that initial thing, maybe pester for a couple days. Then after a week or so, you know, we have whatever we have. And Rachel Freed will be keeping up with this. I started the process. The Rachel Freed will take it over. If we're getting no responses from you, she'll contact you. And the answer may be, I'm not teaching anyone this semester. I'm just here to learn the curriculum. And that's okay, and such as you, David. And
I was going to ask,
oh, yeah,
can you tell how many from each school have applied, even
Yeah.
though you don't have names?
Yep. Rachel can give that to you. She can say, we've gotten 3 back out of your 300 or whatever it happens to be.
300? No.
Yeah.
34.
Yeah. In your case, 34, though we do have some with those kinds of numbers. Okay, I think that's it for surveys. I still have a few more announcements before we get into labs. Lab updates. You know, since we just did the revision this summer and I'm working with Webassign and iterating, I'm trying to keep you up to speed on the lab updates. They've sent back the second round of revisions, which I think I might have mentioned in the last meeting. I can't remember exactly when it came back. And every time they do the updates, all the points get messed up. So lab 1 is done, and I fixed all the points. You have to go in, even though it says in the lab how much each question is worth, there's a different place where you have to enter that. I fixed it for everyone, which was slow and tedious. It's better to do it before the semester, get it right, and then build everyone's off of the correct one. Correcting these things after the fact really kind of sucks. Lab 2S, for 3 of the labs, Lab 2S, Lab 4, and Lab 7, they switched out the question numbers. And I emailed this about you. So what I've done is if you have not exposed Lab 2S to your students yet, I just went ahead and updated it. If it is exposed to your students, I did not because they may have started it, though you're welcome to email me and say they haven't really started it, or I just have them all visible from the beginning of the semester. Give me the update and I can swap it out in a few seconds. Even if you started with the old version, not a big deal. The updates to 2S, between the first update and the second update, it's small stuff. They forgot to update a few figures, but the old figures are pretty much the same. There are a few auto-grading things that I improved a little bit, where it's just giving the point automatically no matter what they answered before. Now I've restricted it to a reasonable range, but they're small things. If you're using the old version of 2, not the old version, but the first update of 2S, you're fine. But if you want the newest version, let me know and I can switch that out for you. Lab 3 I looked at last night. Their updates look good, though all the points are messed up, so that's what I'll be fixing next. I'll be working my way through these, but I feel that now that I'm past Lab 2S, I'm ahead of everyone again, and hopefully I can implement these changes without it impacting your students. Also, Lab 7, they never did the update initially. They were still working on that one. And that was a big change. That's the one where we used the radio telescope. In the old version, they used archival data. In the new version, they'll collect their own data with the 20-meter radio telescope, and that's been pushed as well. You don't see it yet, but you will as soon as I update it. Also, there will be an updated version of Afterglow coming out probably sometime in the next week. I just wanted to show you a few basic things about it. So I'm going to share my screen again. And let's see. So in it's currently in 3 places. You go to afterglow.skynet.unc.edu. That hasn't changed yet. sparge.skynet.unc.edu is our improved version, and then there's an even better version on my programmer's personal machine. And there are some improvements here, most of them still on my programmer's personal machine. He's implementing the final few now. A lot of them are bugs that we've all found over the summer and you found recently. A lot of them are browser dependent issues. A lot of people were going to the information screen right here and not seeing anything. I use Chrome, so it worked, but for some other browsers, it didn't. That should all be fixed. He figured out what was going on there. It was in other places too. We should be good in pretty much all browsers now once this push is made. there's some other small things. Also, there's kind of a format organization difference. It doesn't matter too much. I probably will reshoot a few of the tutorial videos, but not all of them. You see these controls, the zoom, the save, they're now in the lower right-hand corner in the same bar with the pixel and RIDEC coordinates. And up here, we now have a tab structure. The way that works is if you click on it once, it switches what's in that tab. But if you double click on it, then you see it went from italics to regular font, and now it's locked in. So if I click something else, it opens up a new tab until I double click that, and then that's locked in. And for splitting screens, before we had some features here for splitting screens. It doesn't work on this version yet, but what you'll be able to do is just drag. You grab one of these tabs, drag it to the bottom, it will highlight like a box in the bottom, or drag it to the top or to the left or the right. You just drag the tab and it will automatically split the screen for you. So it should be really nice, though you do have to kind of get used to this one-click, two-click functionality. Not a big change, but I just want to let you know. And we will reshoot a couple of the videos for this, but only the ones where it's really pertinent. I'm not going to reshoot all the tutorials just for this. There are other things in here that, Calais, the stuff you requested will be there. They're going to add the WCS button so you can add the WCS to stuff in the sample directory. And also, we do already show the direction, not just in the pixel frame. Like if you're measuring things and you want to know the orientation, we do show it with respect to north. It's not there if you're working with an image with no WCS, but if it does have a coordinate system, it does show that as well already. I think those were the two things you brought up. Okay, and so what are we actually doing today? Lab 2. And normally the way I do this is I'll talk about one version of Lab 2 1 week in detail, and then the next week I'll do the other version briefly and talk about grading. I'm not going to do it this way this time because my TAs are depending on, yeah, they're still here, I'm just checking, depending on these meetings to know what they're doing next week. If we were like a week ahead of where we are at UNC, I would spend that extra week and show that stuff in more detail, but I gotta stay on my UNC schedule, else I'm gonna have an extra meeting and it's not worth it for me. So what I've done, or what we will do, is I'll go through the Stellarium version today. I normally go through the Globe and Lights version because I prefer it, but I'll go through the Stellarium version since everyone's using it, and then I'll just briefly point out the differences with the Globe and Light version. And in terms of grading, what I've done is we did one of these training sessions 1.5 years ago. I went to that video, snipped out the 20 minutes about grading, and I've stuck it in on the YouTube page right here. So when it comes time to grade your labs, you can watch this video, and it'll walk through Lab 1 in particular. And it'll show you how, WebAssign does auto grading for everything it can, but the short answers, the figures, a few other things, you can't do auto grading. Particularly in Lab 1, we don't know what targets they're going to shoot. So a lot of those tables where they say, okay, I could observe these, but not these, it will evaluate all the answers in those tables, but not assign any points. You'll assign the points in the box underneath where they did an honor code pledge. I put it there so you'd actually have a place to assign the points. And that's just because it's different every time, and they could cheat the system by saying I observed everything if it's auto-graded and get all those points. Anyway, it's all described in the video. Also, there is a grading guide, which is an Excel spreadsheet, and we have tabs down here, one for each lab, and this walks you through the manual grading portions. And you don't have to do all this manual grading. My TAs do, but some things, if you wanted to just accept the images, whether they were well done or not, or accept their moon identifications, whether they're correct or not, that's up to you. My TAs go through and actually evaluate the images, evaluate the moon identifications by having Stellarium open in a separate window, and they can just type in the date and time and check and see if they got it right. That's all up to you. These have not been updated yet, but I will try to keep them updated as we go through. So I'll update the lab 1 for the curriculum revisions, and I'll send this link around in one of our follow-up emails. And it's a great tool. It makes it go much faster. And you don't have to use this grading guide, but it's just a suggestion. Okay, this image is worth 3 points. I recommend that if they forgot to zoom in, subtract a point. If it's streaked, subtract a point because they could reobserve, stuff like that. So it's helpful. And that also goes for my new TAs who haven't seen this before. This will be helpful for you. Okay, so any questions before I jump into Lab 2? Okay, Lab 2S, the Stellarium version. I think I opened it up down here. Let me see. Yeah, this is 2S. So we have the introduction at the beginning, and I will, just like I did with Lab 1, I will shoot a new overview video, or I'll break it down into like background, procedure, goals, and then I'll update this text like I did for Lab 1. The key parts are, there'll be a link to the video, and then down here we have special instructions. They'll move up here, and then this is the boilerplate that's the same every time that we went through before. That will be at the bottom this time. So the important thing for this one, other than the students watching the overview video, or you can watch the overview video if you're teaching it, that gives you an example of maybe what you want to do to set up the lab, and they don't have to watch it. But the key thing here is put your observations in for Lab 3. And so I'm going to spend a moment just describing that a little bit. Lab 3 is the Galilean Revolution. Part of that is they pick a gas giant, and they're going to observe it once a day for up to 2 weeks, 1 to 2 weeks. Now, normally at UNC, we use the globe version, globe and light version of Lab 2, which is a 2-week experience. So it works great. I tell them, put in your observations. By the time they're done with the globe and light, which is not Skynet based, I'll come back to that, then all their observations are ready. If you're using the Stellarium version, Lab 2 is really just a 1-week experience. So you may, if you haven't already gotten this far, you may have them put in these observations for Lab 3, second week of Lab 1. When they're learning Afterglow, you, at the beginning say, hey, stop, we're gonna put in the Lab 3 observations. If not, you can do it now. They really don't need 14 observations. If they get 5 or 6 or 7 back, that's enough to determine the orbit. The more they get back, the sinusoid of the thing going around with time is even clearer. So the more the better. But you don't want them putting this in at the last moment. Some people in Lab 1, even though you told them, put your observations in right away, they put it in the last minute. That won't work for Lab 3 because it is a time series over 1 to 2 weeks. So for this, we tell you where to go. And I think I've pulled up Lab 3. It's in procedure section right here. And there's a tutorial showing you how to put the observation in. It's a basic observation, except it repeats. So let me just go to Skynet. I think I pulled that up somewhere over here. Now to show it really quick. So let's say we're looking, it's gonna be of one of the gas giants. They get to pick which one. I think they're all observable right now. So I just picked Jupiter. Yeah, it's up in many sites. And again, you always want to check -12, 20, and 0.5 are the defaults. We don't need the advanced settings. I'm doing this quick because you've seen it before. The lab tells you for which planet what filter to use. Let's see, I'll pull up the lab again, and it's down here. So for Jupiter, V-band 0.03. V-band, continue. And we'll put the 0.03 in a second. Now, which telescopes to use? This is not going to be a pretty picture, right? We're not trying to get details on the surface of the planets. We just want to detect moons. The planet can be blurred out. It doesn't matter. And since we're in COVID and most of our telescopes are down, I'm going to recommend that you don't use only the prompt telescopes. In this case, just use every telescope you have access to. That makes it more likely that you'll get something every night. So for that, you just press the orange dot. It will select every telescope in the time account. I think this is a different time account than the ones you have. The time account I gave you and your students have only the telescopes that are still active in COVID. Stick in my design telescope, and it was 1.03 second exposure. So it's possible in all these telescopes, set prompt 8. In this case, it's too short. And then here's the difference. All that we've done before, that's why I sped through it. But you're going to want to make sure this is clicked, and this is described in the video. Continue on next telescope if interrupted, so they don't get stuck on one telescope, and if it shuts down, they get no data. And then repeat this observation 14 times with at least 1 day between each. Save and continue. It's at least one. Oh, I have a apostrophe in there. 1 day between each there, and then you can submit. Maybe I'll submit it just for shits and giggles. Okay, it's in there. And so that's that. Make sure they put that observation in 1 to 2 weeks before, ideally 2 weeks before, but 1 to 2 weeks before beginning lab 3. Okay, and that's how this works. We'll always jump ahead, put our observations in for an upcoming lab, and then we'll talk about lab 2. Now lab 2 is not Skynet based, and for a number of reasons. One is they're going to be collecting 2 weeks of Skynet data now, so let's do one of the manual labs. It's good to have manual labs. Now the Stellarium version isn't super manual, it's still on the computer, but I prefer the Globe and Lights version. And at the end of the course, there's one Hubble's Law using rubber bands. And the students do like the break in doing the manual labs where they measure things. They like Skynet, but they do like this as well. They sometimes describe, I'd say maybe about a third of them describe the manual labs as their favorite, and 2/3 Skynet. So don't shy away from them. Now, this is the Stellarium version. It's not really manual. The Globe and Lights version, they're Globe and Lights, and they're going to be measuring length of day and how high the sun is above the horizon at midday for all sorts of seasons, all sorts of latitudes, really develop a feel for why it's hotter in summer, colder in winter. And they'll do the same thing here in Stellarium. That's kind of the goal here. And the secondary goal of the manual labs are to cure common misconceptions, right? The overarching theme of the lab sequence is the cosmic distance ladder. But we also want to deal with why is it hotter in summer, colder in winter, because a lot of people get that wrong, and the true nature of the Big Bang expansion in Lab 8, because a lot of people have that wrong in their heads too, understandably. That one's tougher. But this one, everyone should know in the whole population, and they don't. This lab also, at the end, will measure the diameter of Earth, which is the base of the cosmic distance ladder. In Lab 4, we'll use Earth's diameter to figure out distances to things in the solar system, and through parallax, and then use that to get the astronomical unit to get farther, and go out through the distance ladder. So the distance ladder begins here. Okay, that's enough setup, I think. So the goals in this lab is to determine how length of day changes with latitude and season, determine how high the sun is in the sky, how that varies with latitude and season. These are the two primary effects that affect why it's hotter in summer, colder in winter. And the last goal is to measure Earth's diameter. Equipment, just a computer. The Globe and Lights version does have a set of equipment, and I'll show that one in just a little bit. Background sections. So here we define longitude and latitude, and some students get confused when you say line of longitude, line of latitude. They're confused by, do you mean a line of changing longitude or a line of constant longitude? Those are, of course, different things. So at least I get confused. My experience is I get confused more than my students do on this. Maybe it's just my own personal hang up. But in the labs, I try to be really clear. I always say line of changing or constant. And so this is just setting up what they are. You, of course, know this stuff, so I'll go through kind of quickly. And then we show them in Stellarium how to measure this. In the Globe and Lights version, they're going to measure it off the globe. But in Stellarium, for different sites, how do they get the longitude and latitude? So I have Stellarium open. We learned how to use it in Lab 1. Again, F11 will get it out of full screen mode. And you have these locks here. I'm just going to lock those two menus into place. And so we're going to go to the location window. There it is. And here we do a practice, and it's not UNC bias. We just chose it because it's Skynet headquarters, but Chapel Hill in the United States, and here's its latitude and here's its longitude. And we asked them to put that here to the nearest degree with negative signs for west and south. And it'll be auto-graded. In the Globe and Lights version, there's more here. They can calculate a percent error and discuss sources of error. And it's great to talk about the difference between precision and accuracy. But here using Stellarium, you get the value exactly. So that's been cut out of this lab. So background on how to measure longitude and latitude, and then a background on the nature of the seasons. We define the terms, summer and winter solstice, vernal and autumnal equinox. We ask the big question, why is it hotter in summer, colder in winter? And we say, is it because Earth is closer to the sun in summer and farther in winter? And then an emphatic no. We show, I know you know all these things, I'm just running through as if you were students more briefly, but just so you get the idea of the presentation. Here we show that the orbit's almost perfectly circular. Technically, we're closer to the sun in northern hemisphere winter, but it's a small amount. So why do we have the seasons? It's the tip of the Earth. We're tipped by 23.5 degrees with respect to the sun-Earth plane. So that's shown here. So when our hemisphere points towards the sun, we have summer. When it points away, we have winter. And so it switches when we get to the other side because the axis stays relatively fixed, at least on the time scale of years. Over 26,000 years, you have precession, but that's a different thing. And also, when it's summer in the northern hemisphere, it is winter in the southern hemisphere, and we ask them a question about this. We also point out that the term summer depends on your hemisphere. Summer in the southern hemisphere begins December 21st. So summer does not mean July 21st, it means longest day of the year in your hemisphere. Okay, and then we say there are two effects that affect the heat here, length of day and how high the sun is in the sky at midday. The length of day, the longer you're illuminated, the warmer you get, and how high you are in the sky, that's a directness of illumination. Often I like to use a flashlight to demonstrate that. Same amount of energy. Here's direct illumination if the sun is mostly directly overhead, so it's very concentrated. But if it's low in the sky, it's spread out, same energy spread out over a much larger area, so less energy per unit area. And we'll see a figure that kind of poorly demonstrates that in just a second. Okay, then into the procedure, you see we have some about length of day, some about sun's angle above the horizon. And so length of day, I'm going to show you how to do it first for Chapel Hill, and then we'll do it for 5 different locations and 4 different seasons. So I got the instructions here. Maybe I'll put the instructions over on this page so I can glance at them and remind myself, and I'll put Stellarium over here. Okay, so the instructions say that first thing you want to do is point to the sun. So we use the search window, go into the sun. The second thing is you want to make sure you have your right location, Chapel Hill. And we do tell them for this lab, it used to be different. We used to use system time, but that led to problems, people doing this on the, picking cities on the other side of the world and their computer system. System time is the computer clock. They're in a different time zone than some of the cities they would pick. So in the new lab, we just tell them to, we don't set the time zone. It's set by whatever location they select. You see the time zone is changing. If it's a weird place, it just says local mean solar time, and that's fine. I'll put it back on Chapel Hill. Why did it not see it? I'm in the United States. Okay, Chapel. What am I doing wrong here? Am I misspelling Chapel Hill? Yeah, I must have been misspelling it. Okay, sorry. Okay, so we pick the sun, we pick the location, we make sure that we're not using universal time in this lab. That way we'll use whatever time is intrinsic to the place that they have chosen, and get rid of that. And then we're going to change the date and time. For this practice one, it's summer solstice, so set to June 21st. And then we're going to get the sunrise. So I'm lowering the hours until we have sunrise. Couple hints for doing this. One is I put my finger on the sun. You all can't see me doing this, but I'm putting my finger on the sun. And then I'm going to adjust the time until the sun is, until my finger is half above and half below the horizon. You can see as it's setting, you kind of lose the sun. So that's one way to do it. The other is to zoom in. And the sun gets redefined there. And again, you can put your finger on it and adjust it. And the goal is to hit the natural horizon, not the treetops or mountaintops or obstructions, but the natural horizon. It's probably closer to there, half up, half down. Now, in Stellarium, you can put on the ocean mode and get a perfect horizon. But we've amended the instructions to say, keep it here under, I think it's Guérines, France is the scene. And so they're dealing with real obstructions as if they were doing this themselves outdoors. And so that becomes a source of error. So that is the sunrise time. And then they do the same thing for sunset. You can see there are a lot of obstructions here. So I just got my finger in position and you adjust it, and the true horizon's probably somewhere around there.
Hey, Dan, I have a bunch of questions about setting up Stellarium.
Yes, go for it.
Because the new version, they changed a lot of the parameters and how you initialize them. Do you have a standard initialization file for the new version? And also they changed their timing and features also, as far as selecting which timing mode you want to use. There are like about 16 different timing modes in there now.
Okay,
So,
I will have to, thank you for letting me know this. My version is, I think I uploaded, let's say I'm on 0.20.1. So if they've made some major, go
that
ahead.
sounds, I think that sounds like the latest version, but I do know that the parameters, a lot of the parameters in the setup procedures changed as far as, but the basic question is, do you have a standard setup file, initialization file that we can use?
No, when you download Stellarium, there shouldn't be any supplementary files. It should just install on your machine. Though
Yeah, I understand that.
Okay.
But they have configuration files.
I don't know these.
Okay.
So let's stick around after the meeting. We'll sort through it. If I need to, I will amend the instructions for the students. But I need to figure out what this is myself. I don't really know. And I try to upload it or upload a new version once a year, and it just kind of installs and it's ready to go. There are no configurations that I have to select, but maybe I'm missing something. I probably am missing something.
Okay, all right, thanks.
Yeah, so stick around afterwards and we'll share screens and we'll figure that out. Okay, so that's length of day. Let me bring the lab back up here. And so they put it in decimal hours, and so they're gonna have to remember to divide the minutes by 60 for sunrise, sunset, and then they calculate the length of day. I give them the true length of day for this location, which is 14.6 hours for summer solstice, and they discuss sources of error. And in this case, it's difficulty identifying the sun center given the glow, difficulty identifying the horizon given obstructions. There's some other ones that they may mention. The solstice is sometimes on the 20th, not the 21st. And sunrise and sunset don't fall exactly on the moment of the solstice, but these are not significant sources of error. Okay, that was their practice.
That's where I noticed it, by the way. When I was doing my solstice exercise with the students, I noticed that the timing problem. And I'm pretty sure there's a flag on the timing that can be set to get the solstice right.
Okay, so yeah, what I do is, if there's a flag, that's great. I've always just changed the date and time to June 21st, December 21st, March and September 21st. But if there's a flag for that, anyway, we'll figure it out after. And so sources of error, and then they're going to pick a bunch of different places. One place near the Arctic Circle, but a little bit below it. One place somewhere in the Northern Hemisphere. They can reuse Chapel Hill if they want. A place near the equator, a place in the middle of the Southern Hemisphere, and a place just a few degrees above Antarctica. And the place above Antarctica is the trickiest. Well, and they're going to include in the table here with the names and the latitudes, keeping in mind that southern latitudes are negative. But it's hard to find a place close to the Antarctic Circle. And so we give them some instructions for adding a place here. Biscoe Island.
I think there's McMurdo.
McMurdo?
Yeah, it's in there.
Is it
It's a place. And pardon me?
which side of the Antarctic Circle is it on? Is it farther south, or slightly above?
I just usually go into the places and it comes up when I look at location.
Okay, so that will work too. As long as it's a little bit above the Antarctic Circle, it works. If that's the case, we'll change the instructions to say just use McMurdo. If it's a little bit too far south, you can add Biscoe Island. And by clicking on a spot near here, updating the longitude and latitude, you enter the name of the place, and the country would be Antarctica, and then you add it to the list and it's forever there. But that's interesting, McMurdo, I didn't think about it. Okay, and then they list them here, and it's very important they list them from north to south, or else the auto grading will just mess it up and take all their points away. So that's kind of key. And then they put it here, sunrise time, sunset time, length of day. And since they're using local time now, they will all kind of make sense. Before, when they were doing system time, it didn't make sense if they picked a city on the other side of the world. And you don't have to worry about crossing the date line unless you're above or below the Arctic and Antarctic Circle, then it gets a little confusing. And length of day goes here. And I think they get automatic points for the first two, but for length of day, that's what's being judged. They sign their name here, and then they're going to plot it up. And there's a graphing website that we built just for the labs, and it has all sorts of different options for the different labs. And this first lab will use just the curve feature, and we're going to be plotting 1, 2, 3, 4 curves. And you can see as I add numbers in some of these other columns, it adjusts and scales. Maybe it does. There we go. And here they can put labels, like this would be Northern Hemisphere Summer Solstice. It's probably good if they specify Northern Hemisphere, because summer solstice is different in the two hemispheres. Next one, Northern Hemisphere Winter Solstice and equinoxes. So they can label things. They can give it a title. What is this? This is length of day versus latitude. Now the latitude on the x-axis, latitude, type, and they want to put some units like degrees. This would be length, day, and hours. And so that fills all that in for them. Of course, it will look different than this, and they can save it as a PNG. And in the past, sometimes we had issues where the PNGs were too big. And so there's a JPEG as well, which is smaller. It's not as pretty looking. You can see the pixelization, the storage algorithm, but it's there if they need that. And it should look something like this, where, in the Northern Hemisphere, the length of days getting longer the farther north you go, and shorter the farther south you go, and the opposite for the Northern Hemisphere winter. And then here we have the equinoxes, which should both be around 12. this is with data I took on the globe, so it should be more precise with Stellarium. And then they have to explain the graph. So they've gone through this exercise, building up this great intuition about how it works by collecting all these measurements. They've graphed it, but now they have to explain what's going on. And in terms of the grading, this is something that you have to grade yourself. And my experience is it can wear your mind down to a nub. Students trying to explain the concept, they understand it, but the next level is take your understanding it and putting in words that can help someone else understand. And so some of them may struggle there. And I always try to read these generously, trying to figure out what they're trying to say, but it can wear you down a little bit, so just heads up. Second part, I'll go kind of quick here. Second part is sun's angle above the horizon. So here's the flashlight thing where the light gets spread out more. And again, they're going to practice with Chapel Hill, and I'll show you how to do that. Move my instructions over here, move you out of the way, bring up Stellarium. And so let's make sure we're in Chapel Hill. Yep. And summer solstice, that's fine. And I think we're still looking at the sun. And so I zoom out, and I like to grab the mouse and kind of go to fisheye mode. I like to put south on the bottom. And so as I lower the hours, that right there is when the sun is highest in the sky. And you want to get it precisely. So you come over here and look for altitude. And sometimes it's hard to read if you know, with the grass there. So you can go to night mode. That's this little thing down here, and it makes it easier to read the numbers sometimes. So the altitude, and I can actually stop time as well. It's currently 76:58, and I can adjust the minutes. I'm going in the wrong direction. 77. Okay, and it was somewhere around there, 77 and 31. So 78 would be 78 degrees above the horizon at midday. So I've circled kind of the key places and where that special button is, and they can put it here. Again, in the manual lab, they're measuring this off a globe with the protractor, so there will be uncertainty and source of error calculation. And then they're going to do it for many sites. These are all in the northern hemisphere. So they pick the North Pole, something near the Arctic Circle, something between the Arctic Circle and the Tropic of Cancer, and something near the Tropic of Cancer. And for the North Pole, all they have to do is enter 90 in the location window and click on some other box, and that will automatically make it the North Pole for them. They list their cities here, North Pole plus the 3 they chose. The latitudes go here. And how high is the sun in the sky at midday? That goes here. And for Northern Hemisphere winter, at the North Pole, we tell them just to use -23 because it's below the horizon. The highest it gets is 23 degrees below the horizon. Sign their name. They're going to make a plot. And you can see the farther north we go, the sun gets lower in the sky, though it's higher in summer, lower in winter, in the middle in the equinoxes. Then they try to explain it. And then we ask them another question. If you measured this in the south, what would you see? It's basically the same thing, except the curves would be going in the other direction. And then the last thing is setting this cosmic distance ladder, the base of the cosmic distance ladder. We say, imagine going on a road trip on a highway that's north-south oriented. And in fact, we've selected 2 places for them, which helps make the auto grading work if we pre-select the places. One is Winnipeg, Manitoba. One is Omaha, Nebraska. And they're going to look up how long the journey is. It's a pretty straight road, not perfectly straight. And that's about, it's 1,027 kilometers. We tell them it needs to be in kilometers. They measure how high the sun is in Winnipeg, how high it is in Omaha. And that's related to the latitude. So the difference is the difference in latitude. And up here, this is a geometry that we'll use throughout the lab course over and over. Use it for parallax, measuring angular sizes of things. We introduce it here. The difference in latitude, that angle, as a fraction of 360 degrees, is the same as the distance between the 2 points out here on the surface of Earth, in this case, divided by the circumference of Earth. So we go through that math and solve it for them here. So they just have to measure that angular separation, multiply by the distance of the road trip, and that gives them the circumference of Earth, which goes here, and they show their work. Divide by pi to get the diameter of Earth, and they look up the true, I give them the true value, and they calculate the percent error. Talk about sources of error. For this lab, it's mostly just the length will be overestimated because the road's not perfectly straight, though in Google Maps, I think you have the option for the distance as the bird flies. And in the Globe and Lights version, there are some other sources that I'll mention briefly. And then this is kind of a summary. We say, discuss how you would measure Earth's diameter using a shadow casting stick, a protractor, a car's trip odometer, and how do you know it's midday? We've added the question, how do you know it's midday? So that question wasn't there before, so people normally didn't think of that. You go to one location, you put the stick in the ground, you wait until the shadow is as short as possible, then it's midday. You measure it with the protractor, you drive to the other location, the next day you do it. Just a chance for them to summarize what they've just done, establishing the size of the Earth. Questions on the Stellarium version, then I'll just take the final few minutes to describe the difference with the Globe version. Okay, Globe version, let me see if I have it up here. I don't, so let me pull it up. Webassign, it's under my assignments. Okay, now I prefer the Globe version. In the Globe version, you're using a setup like, nope, I pulled up Lab 3. Oh, I'm here, 2G, here it is. Okay, so you're instead using a setup that looks like this. You have a globe and you have a 12-inch ring light. And nowadays they sell LED versions of these ring lights, not the mercury-filled ones that are easily broken. And you'll need some kind of, like stand that you see in chemistry classes and a clamp to hold the ring light. And you want to adjust it to just, move the globe real close, get the ring light at just the right height. 12-inch globe, 12-inch ring light gives you nice planar illumination. And so you have a day side and a night side. And, we discuss this here. And sometimes it's hard to see the division. So the base of the ring stand is a good way to just see where the terminator is as well. And I like this version because although we all figured this stuff out by standing on the ground and looking at it, the Stellarium version does have that benefit. It simulates how you would do it here on the ground. In terms of understanding what's going on, I really think the God's eye perspective is better, where you're out there in space looking down upon the solar system. You can understand the geometry better. Also, the students get to make manual measurements, not with a computer, but with their hand. So there are a lot of positives to this. It doesn't work in an online format. We tried it for years. We sent globes and ring lights all the way to Afghanistan and Iraq back in the day, and they'd mail them back. And it was just very cumbersome and pricey, which is why we made the Stellarium version. But if you can pull this off, this is better. The way you measure length of day is you put your city on the terminator, and then you put the hour circle with noon facing the sun, facing your ring light, and you follow the line of constant longitude, changing latitude up to the ring light and measure the time off. And then you don't need to do it on the other side. Normally, they only work on one side of the apparatus because there's a wall or something on the other side. So they have to indicate whether they're on the sunrise side or the sunset side for the auto grading. But otherwise, it works the same, except they can calculate percent errors and talk about sources of error. And there are, of course, many more sources of error with the globe and the manual measurement. But due to lack of time, I'm not going to go through them. And since no one's using it this semester, I'll skip that. And this part's the same with all the different locations. And the way you measure how high the sun is in the sky is you use a protractor. You get one of those protractors that have a little hole already cut at the 0, 0 and tie a string through it. You can get them in bulk really cheap. Just make sure you get the right kind of protractor that has that little hole. And you hold it flush on the globe and pull the string out horizontal. Not necessarily at the light, because the light's real close. Pretend the light's off at infinity. So you hold it, oh, sorry, my phone. And you hold it horizontal and you measure from south to north. That's how you get those angles. Of course, there are a lot more sources of error that they can discuss. And yeah, and those are the basic differences. The thing is, if you do the globe and light, again, it's not for the online format. And it works great if you have a small class with one setup, like a few students, maybe 2 or 3 form a team, and they can work on one lab kit, you're good. If you're in a room where you can close the windows, have no light coming in, turn the lights out. But if you have to have many of these setups in the same room, the lights bounce everywhere. So you then have to build these PVC cages, and you get black. These lights aren't right. You use a single 12-inch ring light, not this this is an old picture where we're trying different things. See how the Terminator is not straight when you try to jimmy something like this? Anyway, you build these PVC cages, you put black felt over everything, and you also may want to put a dark towel on the table to prevent light from bouncing that way. And the black felt actually covers this side, the front as well, leaving just an opening for the globe. It makes it a little pricier, but you can get everything for maybe about $60 per kit. So it's up to you whether you want to do these. One, you have to have a lab space where you can set these up and leave them up as long as you need for everyone to do all the labs. They do cost a little bit more, but pedagogically, I think it's a better experience. And again, they like the manual aspect as well. And yeah, that's it for Lab 2. So I'll stop and stick around for questions and things. Stop the share. Okay.
So Dan, quick one. I may have missed it. You have a list of the materials to make those?
Yeah, I do have a list. In fact, that was my list, though it's a little bit out of date because it was using those spotlights, which weren't great. But we can get this list updated and with Amazon links. And
that would help if we could. Thank you.
And the nice thing is the protractor and string, you can use it again in Lab 4 for parallax. And at the same time, I can put in the components for Lab 8, which are Hubble's law with rubber bands and tacks, where it really only works if you have the right kind of rubber bands. So I'll make a complete parts list, and I'll bump it to my head TA who's gone. But let me just make a note. An updated parts list, because he spent some time last semester testing every possible LED ring light that's now available, getting the best one for this to work. And with a parts list with links and costs. And probably the whole thing you can get $70, $80 per kit for Labs 2 and 8. Other questions? Okay, if there's nothing else. Hey, Gloria, if you want to stick around, we can try to figure this out.
Okay, but I'm actually not much help in that domain. I've been asking our systems people if they can fix the config file for a couple of years.
The config file for Stellarium. So
to find out about the configuration file, you can look in the Stellarium manual.
okay.
And it's in, I don't know if it's in the appendix, but it's in there. And it has all the features you can turn on or turn off. But the one that's most confusing to me is the time, the whole issue of time in Stellarium and how it handles the time.
Okay, I'm sharing again, and I've opened up the configuration window. So I'll go to time.
Yeah, see, this is all new. The time, the whole thing, all these issues around time.
Okay, so it says when it starts up, it's in system date and time. And that's what I'm reading from this here. And display formats, hour, minute, day. I mean, I think these defaults are fine. With each lab, like in lab 1, we tell the students to change to universal time. And we tell in lab 2, as we just saw, we tell them to use local time. And this is just what you have when you first start it up, I believe. And Lawrence is here, and I know you just installed this for your students, so speak up if any of this, if you have any additional insights. But I think you can run with the...
Can we look at that again? Can we look at that again? Because what about the time, see the time correction?
Time correction, okay, so this is, I'm guessing this is the difference between universal time and GMT. It's just a guess.
No, there's a lot more in there, in that, right? Yeah, there's a lot of, click on that down arrow and you'll see, there's a ton of them.
But
I have no insight into what this is. I'm sorry, into what that piece of it is.
so time correction.
But I think that has to,
Isn't it the time between your where you are in your zone and so on? I mean, isn't it the equation of time? Isn't that what that is?
it's more complex than that. Some of those time correction features are very complex, some of them, that they have listed there.
I would just go with whatever the default is when you load it in. I don't think you need to set it. I've never set it in all my time, and I imagine these are going to be, if it is where you are in a time zone. The thing is, they offer options for selecting a time zone or selecting local time, independent of this. Part of me is guessing, I don't know, let's look one of these up. I'll put it over here, and I'll go to just a browser. Time correction. See, delta T, from what I recall, is the difference between GMT and universal time, and it's only a matter of seconds. Delta T. Let's look at a table to figure out what typical delta. So delta T, this is how much delta T has changed over years. So over the course of just a couple years, particularly in the modern day, and so here we are out at 2000. It's a difference, it looks like a minute, and I'm not sure what it's applied to.
I think those corrections, if someone knew the right correction to select, I think when you're looking at the solstice, it will actually line up the ecliptic and the celestial equator at the right time if it has the right correction.
Yeah.
So that's what I'm saying. So I think that it's more complex than just setting your time zone. I think you have to have the right correction. And when you on that the top one where it says I think it says startup date and time. So you have system time, and you're gonna select other because you want to use GMT there.
Yeah, but see,
Other.
I can change it here. This is when you start it up, it's in system time, but we tell the students to change to universal time. Go here under location. We're going to use a custom time zone, and we just have them select UTC.
Would it be better to have it in the configuration file that it just comes up with the right time set already?
It might be. I mean, well, see, in lab 1, we're going to use it this way. In lab 2, we want them to use their local time. And so we wrote I never even looked at the configuration file. We wrote the instructions based on changing things in this window where they're already going to be to change their location. So I've never messed with anything in the configuration. Whatever it loaded up with as the defaults works just fine. And all the grading has very generous error bars for like when the sun rises or sets because of obstructions on the horizon and things. And I don't think the time I need to look up what this delta T is, but it's clearly less than a minute. And it's either, like Jonathan says, your place in the time zone, which may make a difference if you're in local time versus time zone time. It may be the correction between GMT and universal time, which I recall deep in the recesses of my brain, which is a very small thing. And it's not going to affect anything that they're measuring. Their measurements are far cruder than these small changes. So I think you can just leave the configuration alone when it installs. We never tell the students to mess with it. And any changes in time zone, they do here.
Okay.
I think it's simpler for the students if we send them to fewer windows to change things.
Oh, right. I wasn't expecting them to change it. I was just wondering about the configuration file that executes when the Stellarium is set up, if you had any special settings.
And
That one's a real curiosity to me, because I'm talking about the distant nature Stellarium exercise for that equinox. Those are free. If you go to that OER, you can get a lot of Stellarium, a whole package of Stellarium exercises called distant nature. And it's just very annoying to me to use the one for the solstice with the lines not lining up at the right time.
Okay, yeah.
So I know it's something
with that package of exercises, but for the Skynet labs, I don't think we need to mess with it.
Doesn't look like it.
Yeah, but I can see there's other things that would matter. Lawrence?
I have to leave. I'm sorry, but I just was saying goodbye and thank you.
Oh, sure. Yeah, totally.
Okay. Thanks.
We have anything else?
Okay. Were you going to show us about setting up the WebAssign? Because today I'm going to have to take the new student and get his eCampus, which is a D2L system, set up so it links to that WebAssign.
Okay, yeah, I can walk you through that. So let me share again. And let me go to my WebAssign, because I think I've set up all your courses.
We're going to have a new course to go set up in there.
Oh, okay, so.
He's going to have a different course number.
Okay. So let's see, you have 2 courses right now that are already set up. These are Physics 150.
Right.
And so if you have another course, just add another line to this spreadsheet. I'll put the link in the chat window right now.
Okay.
You don't have to go digging through your email. And yeah, just add another line and I'll create another course. It'd be no problem.
Okay. All right. Thank you.
Sure. My pleasure. Talk to you next week.
Okay. Now, who do I talk to about the D2L to the WebAssign connection? My systems people?
The D2L, what's that?
It's our learning system where we have all our courses. It's like the websites for our courses are in D2L.
Okay, yeah, I'm not familiar with that, but
okay.
WebAssign it's a textbook. View it as a textbook. With these labs anyway, it's a textbook. It's just an online textbook with its own platform. It does do homework assessment, obviously. Some institutions use it as their primary platform, but even if you're using a different platform, they can still purchase this as a textbook. It's an interactive online textbook that helps the instructor with the grading. So it can be completely separate.
No, I'm gonna do it the whole formal way, start to end, so I can just see it this semester how to do that whole process. And I'll let you know. I'm pretty sure, I know we have other courses that are already using that Cengage WebAssign. So I think somebody in the information technology can help me set it up, and I'll fill out the form so you'll know what the number of his course is.
Okay. Yep.
Okay. Thank you, Dan.
Sure. My pleasure. Next week.
Okay. Bye.